Okay, this would be section 7.4, exponential functions and their graphs. And before I get going too far into this, I just wanted to say thanks to everyone for all the feedback on the flipping the classroom. I'm going to think a lot about it and try to make some changes that I can to make this better for you. So anyway, on this particular topic, basically there's two different things we think about. One of them is called exponential growth, and the other one is called exponential decay. And so exponential growth is something like, for instance, say you heard a rumor, and you're chatting with your friend, and so the both of you have heard some kind of a rumor. So there's two people, and then say each one of you goes out and tells two more people this rumor. So then we now have 2 times 2 people who know. And then each one of those people go out and tells 2 people the rumor. So now we got 2 times 2 telling 2 more, etc. Maybe you can see where this is headed, and you can see what happens to a rumor. So this scenario, where really what we have here is 2, 4, 8, etc., is what we call exponential growth. In this particular situation here, we could model with an equation like that, which is called an exponential. I'm going to show you that on the calculator here in 1 second. Okay, the other thing that we look at is what's called exponential decay, and if you're taking chemistry, you may have heard about this a little bit. And this would be something like half-life of an element, where maybe we start out with a gram of an element, and then after a certain amount of time we have a half of a gram, and then after a certain amount of time we have half of a half of multiplication of a half, which is a fourth, and then we get half, that fourth, and we get half of that, etc. So in this case we're looking at 1, 1/2, 1/4, 1/8, etc. And hopefully you can maybe see a little bit of a connection here to the sequences that we met in the last chapter. So I could write this scenario as f of x is equal to 1/2 to the x power. So you notice these things called exponentials, we have a number sitting here in the base, but the thing that makes it an exponential is that we have an x, a variable, in our exponent position. And just to make sure this makes sense then, notice like on this one, if I put in a 1, 2 to the first is 2. When I put in a 2, 2 to the second is 4. When I put in a 3, 2 to the third is 8. Now likewise over here, if I put in a 1, a half to the 1, I get my half. A half to the 2, I get my fourth. A half to the 3, I get my eighth. So we do, in this situation, in order to get this 1 that we started with, we would have to think of putting in a 0 here for this x. So let's just take a look at these just for kicks on the calculator for a minute. So I'm going to go ahead here and I'm going to hit y equals. I'm going to try to hit y equals, that is, of course. Close this out again and bring it back up. And I'm going to type in 2 to the x. So we'll look at exponential growth first. Now sometimes, and I don't know if you've ever done this, but I'm going to go ahead and change the mode on my calc, and you might find this helpful at times. There's actually another mode on our calc where we can, and I'm going to just cursor on down here, where we can actually look at a graph and a table at the same time, and sometimes it's sort of interesting to do that, so I'm going to do that in this particular case. And I'm going to go ahead now and I'm going to hit graph and see what I see. Okay, so I can see my graph on the left side and I can see a table on the right side. And if I want to actually get so I can move around in my table, I'm going to go ahead and hit my second graph button, and that will bring my cursor into my table. And you know what? I need to do one other thing, and that is I am going to go ahead, and maybe your calc is in this mode also. I'm going to change my calc mode into auto. And then I'm going to go back to my graph again. And I'm going to hit second graph for table, and this just allows me to move around, and while I'm moving the cursor also moves on the graph, which I think is kind of an interesting thing. So you can see as I get further to the left here, the number gets really, really small. Now in reality, I never get to actual 0 here, even though my calc might start running out of space and make me think that. I'll talk more about that in a second. But by looking at it in this way, I can then actually go down and say, oh yeah, if I put 2 to the first power, I get 2. I put 2 to the second, I get 4. 2 to the third, I get 8, etc. And this is how, and I'm not going to really practice it here, but you need to be able to graph these. But you've graphed many things, so I think you'll be able to graph these also. So now, just for kicks, I'm going to hit y equals, and I'm going to put this other thing in, this half to the x power. So this is what we were using to show decay. So a half, I'm just putting it in as a decimal to the x power, and I'm going to hit graph on that. Okay, so now you can see hopefully something interesting here. The original one, y equals 2 to the x power, is looking something like this, and y equals 1/2 to the x power is looking something like this. So just to think about why it looks like that, and hopefully it has a look to you of being a reflection in the y-axis, I'm going to go back and just write a few more things down here about exponential functions. So, in reality, just to kind of generalize what these exponential functions are, we have y equals, I could write f of x equals, but I'm going to just write y equals b to the x. And b being our base. And we're going to see, the more we work with these, that as long as b is bigger than 0, and b is not equal to 1, because if b was to be equal to 1, if I put a 1 in for b, 1 to any power is 1, and I'm just going to end up with a horizontal line. So if that's the case, that b is greater than 1 and b is not equal to 1, we're going to have what we call an increasing function. And that's, if you read the function like a book from left to right, you're going to see it just going up. Now, when we just put a half in there, we notice, hopefully then, that in that case what happened was, so we're saying basically b is a fraction, it's between 0 and 1. So what happened in that case was we had what we call a decreasing function. I don't want to draw it like that, actually, just to be a little bit clearer about that. It is decreasing, but not in that way. It's decreasing like this. Now, why did that happen with this y equals 2 to the x and y equals 1/2 to the x? I'm just going to go back to my graph for a second. I'm going to go ahead and I'm going to change my mode back so I can see the whole graph. Just wanted to introduce you to this other way to look at your graph. I'm going to come on down here. Change it back to a full screen. And just take a look at these. So I'm going to go ahead and hit graph, and the first thing that you see is going to be y equals 2 to the x, and the second thing that you're going to see is going to be y equals 1/2 to the x. And so if you think about it, y equals 2 to the x, if we're going to have a reflection occur on the y-axis, if you think about what happens reflecting in the y-axis, is if I have some point here that's positive, if it reflects on the y-axis it becomes negative. So the x value is basically changing from positive to negative. So if that was my original function and I change this to 2 to the negative x, what I really have, I can think of it as another way, is I have 2 to the negative 1 times x, and hopefully from what we've learned so far in this chapter, 2 to the negative 1 is really the same as 1/2 to the x. So that's why when we put y equals 1/2 to the x, we ended up with a reflection over the y-axis. Okay, just a couple other things. This really, learning about this, and you're going to see this on the quiz, is really more about sort of recognizing what these things look like and being able to graph them. So another thing to look at is, well, if I have y equals 5 to the x, I have y equals 3 to the x, I have y equals, say, 5/2 to the x. The question is, how do they compare to each other? So I would suggest you maybe try putting those into your calc or think about it for a second. Like, well, what goes on here? If I have like y equals 5 to the x, then 5 to the first is 5, 5 to the second is 25, 5 to the third is 125. But over here, I have 3 to the first is 3, 3 to the second is 9, 3 to the third is 27. The numbers aren't getting as big as fast. And then over here we have a different scenario. Now 5 halves though is a fraction, but it doesn't necessarily mean it's between 0 and 1. So I'm going to go back to my calculator here for a second and throw them in there. Maybe you could look with me or you can try it with me on your calculator. I'm going to go in and I'm going to put in 5 to the x. Come down here. I'm going to put in 3 raised to the x power. And I'm going to come on down here and I'm going to put in 5 over 2, which would be 2.5 raised to the x power. So hopefully you see then what's happening here is I have a 5 and a 3 and then I have something in between. I'm going to go ahead and I'm going to hit graph here. And remember, your graph graphs the first thing, then it graphs the second thing, and then it graphs the third thing. Now one thing I might do just to make this a little bit easier to see is change my window. So I'm going to change my window here to go from -5 to 5, and I'll drop down here, and since I really don't care about the negative so much, just keep my x-axis on there by typing in a -1. And so then maybe you can see what's going on a little. So that's y equals 5 to the x, that's y equals 3 to the x, and then when we drop down a little bit below, you can see how it's the steepness of how fast it goes up is slowing down based on what that number is. I guess that's all I'm going to talk about for now. There is also y equals e to the x, which I'm going to mention briefly in class tomorrow. So if you go to your quiz, it will be an opportunity to sort of take a look at some of these graphs and see if you can interpret some of them. And just think about this a little more. So y equals e to the x. So go give the quiz a try, and that's the end of the section.